Hello, welcome to this lesson and video. We are looking at connected particles, and this is the question that we are going to handle. And it reads: a body of mass 8 kilograms rests on a rough horizontal table and is connected to another body of mass 3 kilograms by a light inextensible string passing over a smooth fixed pulley. The 3 kilogram mass hangs freely. The coefficient of friction between the table and the 8 kilogram mass is 0.3. If the system is released from rest, find the acceleration of the system, the tension in the string, and the distance the 3 kilogram mass covers after 2 seconds. So here is our illustration. The illustration showing all the forces on the system of connecting the 8 kilogram mass and the 3 kilogram mass. So the 8 kilogram mass has a frictional force which is opposing its motion because it's on a rough surface. Then it has the weight 8g and the normal reaction R. The string has a tension T, and the 3 kilogram mass has a weight of 3g. So let us begin resolving. So for the 8 kilogram mass, it is moving in this direction, being pulled by the 3. So the T is greater than F. So our resultant force will be T minus F equaling to MA when we use the second Newton's law of motion. So when we substitute for F, F is equal to mu R and R is equal to 8g. So we shall say T minus mu times 8g is equal to 8a, and that becomes our equation 1. Then we consider the 3 kilogram mass. It is moving downwards, so 3g is greater than T. So the resultant force is 3g minus T equaling to 3a. So we add the two equations to eliminate the T. So we shall have T minus 8g mu plus 3g minus T is equal to 3a plus 8a. So we shall have negative 8 times 0.3, which is the coefficient of friction between the table and the 8 kilogram, times g plus 3g is equal to 3a plus 8a. So we say 3g plus 2 minus 2.4g is equal to 11a. So that would give us 0.6g equaling to 11. Then we divide by 11, and that will be 0.6 over 11g, which gives us 3 over 55g, and that will be in meters per second. So that will be the acceleration. Then for tension, we are going to choose equation 3 because it is equation 2 because it is easier to substitute. So we shall collect when we rearrange, T is equal to 3g minus 3a. Then we substitute for the value of a, which is 3 over 55g. So 3 times 3 will give us 9. So we shall have 3g minus 9 over 55g, and that gives us, when we calculate, 156 over 55g newtons. Then we go to find the distance covered after 2 seconds. So we shall use S equaling to ut plus half at squared. We have the t, we have the initial velocity, which is 0, and then we have the acceleration. So by substitution, we shall have 0 times 2 plus a half times 3 over 55g times 2 squared. So 2 squared will give us 4, and then when we cancel the 4, 2 by 1, 2 by 2 times that, so that will give us 6 over 55g meters. Thank you. If you like this video, subscribe to my YouTube channel, like it and share.